Welcome to this episode of Robert's Creative Chronicles. So today we'll be solving this question, which states that find the real root of the equation exponential x sin x is equals to 1, which lies between 0.5 and 0.6 using false position method. Perform 4 iterations. So solution. So now we'll write this function. The function it will be f of x is equals to exponential x sin x. Then we'll bring this one to the other side, minus 1. Now this is the function we are going to work with. So now this method uses two initial approximations to the root. So these are the two, 0.5 and 0.6, like in secant method. So now you can use anyone use as your x0 or x1. You still get the same final answer for the approximate root of this equation. But your workings, the beginning of your working till before you find the final answer will be different from the person that uses the reverse. But the final answer will be the same. So at the end of the day, you still find the approximate root of this equation, even though you use any one. So let's use x0 equals to 0.5 and x1 equals to 0.6. So now we'll write the general formula for the false position method. The general formula is given by xn plus 1 is equals to xn fx0 minus x0 fxn. Then over this minus this, it will be over fx0 minus fxn. You see? So in this one, n is equals to 1, 2, 3 to infinity. So this one, n is not equals to 0. N starts from 1, 2, 3, just as in secant method. So now we can start. First, we have to find fx0. And we know that when we substitute 1 here, so here will be x2, here will be x1, x1, x1. So we have to find fx1 also. So we'll find fx0 and fx1. So this will be what? Fx0 is equals to what? F. So it will be f0.5. It will be f0.5. Then this is what? Exponential 0.5. We can also, now since we are using in terms of n, we can say this equation now becomes, we can add n to it to be xn sin xn. So it will be fxn is equals to exponential xn sin xn. So it will be in terms of xn. So this exponential 0.5 sin what? 0.5 then minus 1. So now one thing I want you to know that is very important in doing numerical analysis and you are handling trigonometric functions like sine, cosine, or tangent, you have to, when you are substituting the value in the when you are putting the value in the calculator, you have to put the mode to radian. You have to put this mode to radian. If not, you will not get the final answer. If not, your iteration will not even converge. You'll be getting different awkward answers that will not make sense. So you have to put your calculator in radian mode before you put trigonometric functions. So when you are putting trigonometric functions in your calculator, you must put it in radian mode. If not, you will not get the correct answer. So this now becomes exponent. After you put it in radian mode, you can see r. Then you say exponent of 0.5 sine 0.5 minus 1. So this is negative 0.2096. You see? Now, imagine we didn't put it in radian mode. This is 3. So now I put it in degree to show you. So you can see how different it is. So make sure you always put your calculator in radian mode when you are doing numerical analysis on trigonometric functions. So now the next one, fx1 equals to f of 0.6, which is exponent of 0.6 times 0.6 minus 1. Zero point 0.02884. So now imagine we put it in degree. Imagine we did not change it to radian. This exponent of 0.6 times 0.6 minus 1. So you have put, you see, now this is in degree. The answer it gave us is negative 0.9809. And the last one it gave us negative, it's also negative 0.98 something. So now it's trying to tell, and the root lies between 0.5 and 0.6. So now it's giving us two negative values, which cancels, which implying that the root does not lie between 0.5 and 0.6. When the root lies between the two numbers, it should give you one negative, one positive. And this one, if you use degree, it will give you two negative values, meaning that the root is not even within this interval, 0.5 and 0.6. So you can see that this degree is wrong. So never use degree in numerical analysis to solve trigonometric functions. So now we'll start the iteration. N is equals to 1. This is my first iteration. N is equals to 1, we'll substitute it here to be. But fx0 is constant. So fx0 will not change. And this f function of x0 and this fx0 or x is the same thing. Fx0 will not change. And x0 also will not change. So it will be, it's constant, so it will be. This x2 is equals to what? x1 fx0 minus x0 fx1 over what? fx0 minus fx1. So we'll now substitute. So x1 is what? x1 is 0.6 times fx0 negative 0.2096. Then minus x0 is 0.5 times fx1 is what? 0.0288 over what? Over this minus this. So is this minus 0.2096 0.0288. So now we can put this in the calculator. It will be 0.6 times minus 2096 minus 0.5 minus 0.5 times 0.0288 negative 0.2096 minus 0.0288 is 0.5879. So this is approximately the value for x2. Then we'll find the function of this x2. fx2, which is f 0.5879, so now we substitute it to be exponential. Exponent of it, sine of it, minus 1. It will be exponent of 0.5879 sine 0.5879 minus 1. Make sure it's in radian. Exponent of 0.5879 sine 0.5879 minus 1. No, there will be two zeros before this 1, so it will be 2 zeros and 1 6. Negative 2 zeros 1 6. So this will be what? Negative 0.0016. So now we'll do the second iteration. N is equal to 2. This is the second iteration. So when we substitute n is equal to 2 in this equation, we'll get what? It will be x3. x3. We can add 1 here. So here will be x3, then here will be x2, f of x0, which is constant, minus x0, which is also constant, and f of what? x2 over f of x0 minus f of x2. So this is it. Let's substitute the values inside. x2, where's x2? x2 is 0.5879. 0.5879 times fx0. Okay, fx0 here is the same, so we can take this and this and this. So it will be what? Minus 0.2096 minus 0.5 times then fx2. fx2 is what? Is minus 0.0016. Minus 0.0016 over what? Over this minus 0.2096, then minus fx2, which is this. So it will be plus 0.0016. That's it. So now we can put this here. 0.5879 times minus 0.2096 minus 0.5 times negative 0.0016 over what? Negative 0.2096 plus 0.0016. So this is 0.5886. It's approximately 0.5886. So now, then we'll find the function of this. It will be exponent of this, sine of this, minus 1. So make sure it's in radian. 586. There will be 3 zeros before this one. Then this one approximately becomes 2. So it will be 0.0002. So now we can do the third iteration. So n now is equal to 3. This is the third. So when we substitute n is equal to 3 in the original equation, we'll get what? X4 is equals to what? X3 fx0 minus x0 fx3 over fx0 minus fx3. So now we can substitute the values inside. We will get x3 is what? Is 0.5886. Then fx0 is the same thing here. Fx3 is what? 0.0002. Fx0 is negative 0.2096 minus fx3, which is this, so now we can put this in the calculator. 0.5886 times times negative 0.2096 minus 0.5 times 0.0002 minus 0.2096 minus 0.0002. So this is 0.5885. You can see that there's no much difference between this and the previous answer. So our iteration is getting very close. So x4 is equals to 0.5885. Some people even terminate the iteration because the difference is 0.0001. But since in the question it was asked we should do 4 iterations, so we can just do the 4th one. Our answer will still be very close to it, or even the same as this. So we'll find the function. So we'll find the function fx4 equals to f 0.5885 to exponent of 0.5885 sine 0.5885 minus 1. So make sure it's in radian mode. Exponent of 0.5885 sine 0.5885 minus 1. This will be what? Since it's negative 10 raised to the power minus 5, it will be you will find 4 decimals before this 8. So approximately to be 0.0001 since there's 8 here, or it's negative. So it will be negative 0.0001. So now we'll do the last iteration. N is equals to 4. This is the 4th. So now it will be what? X5 is equals to X4 f of x0 minus x0 fx4 over this minus this fx0 minus fx4. So now we'll substitute. X4 is what? Is 0.5 885. fx0 is same thing, negative 0.2096 minus 0.5. Then this, the function of x4 is negative 0.0001 divided by this minus this minus this, which will be negative 0.2096 will be plus, since there's minus here, 0.0001. So now let's put this in the calculator. This is 0.5885 times minus 0.2096. It's the same thing, it's still the same thing, but if you put 0 or not, it's still the same thing. So minus 0.5 times minus 0.0001 minus 2 plus 0.2096 plus 0.0001. So this is 0.5885, you see, like the previous answer. So we can stop our iteration now. So we are convinced that the approximate root of this equation is 0.5885 to 4 decimal place. So now x5 is approximately equal to what? 0.5885. Now since x4 is equals to x5, since x4 is equals to x5, therefore the approximate root is equals to this one, which is 0.5885. Now since x4 is equals to x5, this one is equals to this, the approximate root is 0.5885. So we can now stop the iteration here, and we know that our approximate root is 0.5885. I hope you understood this episode. If you have any question, feel free to contact me using my WhatsApp or email written in the description below, or you can write them in the comment section. Thank you for watching. Please don't forget to like, share and subscribe to my channel, and hit the notification bell to get notified as soon as I drop a new video. Thanks.